Right, today we're going to do inverse trig integration, which is section 5.7 in your book. Let's look at inverse trig. Okay, so first we have these derivatives. If you recall, the derivative of arcsine is u prime over the square root of 1 minus u squared. Arctan is u prime over 1 plus u squared, and arcsecant is u, absolute value of u, square root of u squared minus 1. So kind of my mnemonic trick for memorizing these is arcsine has the I, which I remember the 1 comes first. Arctangent has a T for two things different than this one. The two things that we changed were now we have no square root and we have a plus, and also the plus and the T go together. And then arcsecant, I remember secant has a second U and then they're by each other. So that's kind of my tricks for remembering the formulas. Now we're going to talk about the antiderivatives of these guys. So here are the antiderivative formulas. The integral of 1 over the square root of a squared minus u squared is arcsine u over a plus c. So a can be any number. It doesn't have to just be a 1, which is where the u over the a comes in. This one is 1 over a arctan u over a, and then secant is 1 over a arcsecant absolute value of u over a. So when we're looking at these, let's talk about how we know it's not something else first, like it's not just general u sub. If this had an x up here, it would be u sub, because if I made the inside u and I took my du, this 2x will divide out. That x and that 2x will cancel. So I would do u sub if there was an x on top. But when you have a constant on top and then you have an x squared, that's when you need to kind of think maybe it's inverse trig. So that's how you recognize these problems. Then you have to figure out which of these three is it. Well, when you have the number first minus the variable, then that means it's sine. So what you're going to do is you're going to see that this is a squared. So if a squared is 4, that means a is 2, which means this is u squared. So u is x, and so du is just dx. So this is just arcsine u over a, so x over 2 plus c. Now this one, I just have 4 times that formula. I could bring out the 4. And this is just arcsine's formula exactly. This is your a and that's your u. And so this is just 4 arcsine x over 1, which is just x, plus c. Because we have the number first minus the variable. So that's how we know it's arcsine versus arcsecant. Let's look at this one. Okay, I still have a number first, which makes me think arcsine. But so this is my a squared is 1, which means a is 1. This one is u squared is 4x squared. So then my u is actually the square root of this, which is 2x. So then you need to find du if it's anything but just x. My du would be 2 dx. So that means you're going to divide by a 2 or have a 1/2. So if I was to rewrite this, I would have 1 over the absolute value, the square root of a squared minus u squared, and then I'm going to have my du over 2. So you're going to have your 1/2 in front, and then arcsine u over a, so u is 2x this time, over 1 plus c. Now this one is different. You see that you have them by each other. You have the variable first as well. So if the variable minus the number, then that means arcsecant. So you're going to try to make this u squared, which then would make u be x, and then a squared is 4, so a is 2. And so if I was going to write this, the formula, I have 1 over, that is u, and then have u squared minus a squared, and dx is du, so it works out to be 1 over a, the one at arcsecant has 1 over a, arcsecant, and then absolute value of x over 2 plus c. You have to have absolute value in there because you have to have a positive argument for arcsecant. Okay, this one, I have, if that is my u squared, is 4x squared, then my u, and your u first is 2x, so my du is 2 dx. And then I have So solve for dx, that'd be 1/2. And then I have a squared equals 1. So I would have 1 over, let's just write 1 over x. Then I have my u squared minus 1. And then instead of writing dx, I'm going to write 1/2 du. Okay, and so here's the thing though, I want this to have a 2x in order for it to be the formula that needs to be u here. And it works out that it is u because I have this 1/2 and I have this x. So I really have 1 over 2x u squared minus 1. And that 2x is actually my u. So it works out that this is the formula. And so the answer is 1 over a arcsecant u over a plus c. So that 2 actually needed to be there to go with this 2x to be the u, because the formula is the integral of u, and then u squared minus a squared is 1 over a arcsecant u over a. So you have to have that u out there, and this u was 2x. So it worked out that this 2 can multiply by that x and be sit here as your u. This one, you notice that we have a plus and no square root, so it's tangent. So u squared is 9x squared, so that means u is 3x. So du would be 3 dx. So I have 2 over 1 plus u squared, and then dx is 1/3 du. So I'm just going to have 2/3 out front, 1 over 1 plus u squared. So my answer is 2/3, and then arctan 1 over a, my a is just 1 though, arctan u over a plus c. So you don't have to have this 1 over 1, I just did that for emphasis. Let's look at the next one. Okay, so this one, if we make our u natural log, our du would actually be 1 over x dx. We solve for dx, we get x du. Okay, so if I rewrite it, I get 1 over x and then the square root of 1 minus u squared, and then dx is x du. So these cancel, and so I'm actually just integrating 1 over 1 minus u squared. So again, I have that number first, which means it is arcsine, not arcsecant, because this x here is actually there because it's the du and divides out. So the answer here is just arcsine, natural log of x plus c. Okay, this one is a little bit tricky. Let's think through it. If my u is cosine of x, my du would be negative sine of x dx. That means that would be your a squared because there's a plus, so a would be the square root of 7. So let's see if it would work out. I have sine x, and then that would be, that was my a squared plus my u squared, and then solve for dx, that would be du divided by negative sine x. So these cancel, and so you have your tangent formula there, but just negative, so negative 1 over a squared plus u squared. So my answer is going to be negative 1 over a, so that's root 7, arctan u over a plus c. Let's try the next one. All right, this one's a little tricky. I don't see a square root, and but I do see a plus. Let's see what happens if we make this u squared. That means u would be the square root of x, and then du would be 1/2 x to the negative 1/2. Or that would be 1 over 2 square roots of x dx, and if you solve for dx, it would be 2 root x du equals dx. So if I try to rewrite it using that information, I have 1 over root x, and then I have 1 plus u squared, And then instead of writing dx, I write 2 root x du, because that's what it's equal to. So that means this root x will cancel out, which means that this is a tangent, arctan. And it's just 2 times that. So 2 over a, but a in this case, I didn't write a, but a is just 1. And then arctan, u is actually the square root of x over a, but we don't have a as 1, and then plus c. So my recommendation is, again, to look for the plus for arctan, the minus for arcsine or arcsecant. If it's the number first, try arcsine. If it's the variable first, try arcsecant. Sometimes we need to split our definite integral in order to integrate it. So this problem here, we need to split it apart to make it work. So I have x squared over x, square root of x squared minus 4, and then plus 8 x squared of x squared minus 4. This simplifies to be just x on top. Now, this one is what I was trying to explain earlier. It's actually just u sub. It's not anything too tricky because this is 1 power less than that. So its derivative will cancel out. The derivative is 2x dx. Remember, you can just divide by the derivative. Or if you want to rewrite the integral, you can rewrite it. I didn't mean to cancel out that dx. Dx is equal to du over 2x. So I would have my x, and then dx is du over 2x. So the x's cancel, so you just get the 1/2 du there. So I have 1/2, and you're integrating x squared minus 4, or sorry, I should write u. This is u. Okay, so I have 1/2, and then I have u to the negative 1/2 du. So the antiderivative to that, you add 1, so add 2 over 2. So that'd be u to the positive 1/2, and then you multiply by 2. Because you divide by the this fraction, there's multiplying by the reciprocal. And so I get u to the 1/2. So this first integral is just the square root of x squared minus 4. This one, we look and see what we have. We have the variable first. So we're going to try arcsecant. So u squared is x squared, which means u is x. A squared is 4, which means a is 2. And we can put that 8 out front. So that is like 8. And then I have, oh, I didn't write my dx. Okay, so dx is just du in this case. And so it works out that we have 1 over u squared of u squared minus a squared, which is arcsecant. So the integral to that is going to be the 8 times 1 over a, so over 2, arcsecant u over a plus c. So then that becomes 4. So this is our answer, square root of x squared minus 4 plus 4 arcsecant, absolute value of x over 2 plus c. Sometimes we have to complete the square in order for it to work out, especially tangent. The way that we get the complete the square to work is, and what you do is you kind of leave some space between the term that has x and the term that has the number. And then what you do is you take this and you divide it by 2, and then you square it, okay? And then you add and subtract so that you're actually not changing the overall value. So I'm going to take 8, I'm going to divide it by 2, so that would make me get 4. And then I'm going to square that, which gets me 16. So I'm going to add 16 here, and I'm going to subtract 16 here, because then I actually added 0. But now that works out so that this first part here becomes x plus or minus whatever that was halved, so 4 squared. And then over here, you just simplify whatever that is. 9 minus 16 gives me a negative 7. And so this is another way of thinking about that. If I wanted to do this one, you need to be really careful with the negatives. Okay, so I would just factor out a negative from both of these things. So that'd be minus 2x. So what you're going to do, divide that by 2. So that'd be negative 1. And you're going to square that. So it'd be 1. So you're adding 1. But then here you're actually subtracting the 1 because it's in this, it's grouped together. So then that means you need to subtract 1. add one, because we subtracted one, so then you need to add one. And so if I multiply this out, I would get the same thing that I started with. This is negative x minus 1 squared plus 1, or 1 minus x minus 1 squared, depending on which way you need to write it. Okay. So let's see if we can figure out this one. So we'll complete the square here to see if it helps us out, because we want a quantity squared, like a variable squared, and then a number. So I'm going to leave some space. I'm going to half 6. What's half of 6? That's 3. Then you square that. That would be 9. So you add 9 and subtract 9. So when I do that, I get x minus 3 squared plus 8 minus 1. That's minus 1. So I have variable minus number, which helps us think that that's going to be arcsecant. I also have that sitting right here. So this is just arcsecant, because this is our u, and that's u squared. So your answer is going to be 1 over a is just 1, arcsecant u over a, which is 1 plus c. Okay, we have that negative thing here. So I'm going to factor out negative from both those terms. It just helps me see it better. So I have negative 4x, half it, that'd be negative 2. Square it, so you're going to add 4, but you're actually subtracting 4. So then I need to add 4 right here. So then I'm going to rearrange the way that's written to be 4 minus x minus 2 squared. You just half this to see what the thing is that you're adding or subtracting and the quantity squared. So now I have my number minus my variable, which means arcsine. Your u is x minus 2, so your du is just 1. Your a squared is 4, so that means a is 2. So your answer to this is going to be arcsine u over a plus c. This is going to take a little bit of practice before you get used to it. Evaluate the definite interval. Okay, so this one, I notice I have e to the negative 2x, and I have e to the x, and that is that squared. So let's see what happens. And this is a number 1 minus a variable, and so let's try arcsine. So u squared is e to the negative 2x. So that means u would be e to the negative x, and then du would be e to the negative dx. I mean, e to the negative x times negative 1 times dx. So if I divide it by negative e to the negative x, that is what dx is equal to. So if I was to write this, I would have e to the negative x over the square root of 1 minus u squared, and then dx is du over negative e to the negative x. So those simplify to give me just this negative 1, which I could bring out front. And so this is arcsine. That's arcsine's formula. So we have negative 1 arcsine u over a. U is e to the negative x. A is just 1. And so then I can plug in my bounds. Natural log of 2, natural log of 4. So let's see. If we do that, we will have negative arcsine e to the negative ln 4 minus the negative, so plus arcsine e to the negative ln 2. So that negative, if you want to simplify this, you can bring the negative as an exponent, so that'd be to the negative 1 power. And so really what this is negative arcsine e to the natural log of 1/4, because 4 to the negative 1 is 1 over 4 to the first. The reason why we want to do that is because then we can cross out this e in this natural log and say negative arcsine of 1/4. And then plus arcsine of, that's going to cancel as well. That'd be 1/2 of 1/2. Okay, so arcsine of 1/2 minus arcsine of 1/4, and you can just leave your answer like that. You could evaluate arcsine of 1/4 using the unit circle. It would be 5 or 6, but but that answer is also correct. So now this one, let's see. I know this isn't just normal use set. I know that because if I want to try to cancel the derivative of this is 4x cubed, but is that an x cubed? No. So that means it's not just like natural log or something where I could cancel out the du. So we're going to try arctangent. The reason is because we got this plus. So let's say that u squared is x to the fourth. That means u would be x squared, and so du would be 2x dx. Okay, so I'm going to write this x there still, and then that's my u squared plus my a squared. So a squared is 4, so that means a is 2. And then dx is du over 2x. So those x's cancel, so I have 1/2 1 over u squared plus a squared du. So this is arctan. So 1/2, and then it's going to be 1 over a arctan u over a. U is x squared over 2 plus c. This is your 1 over a, and this is because of the du, right? So I have 1/4 arctan x squared over 2 plus c. Oh, whoops, not plus c. We're supposed to evaluate it. My bad. Not plus c. I got to plug in the bounds. 1/4 arctan, plug in root 2 first, root 2 squared over 2 minus 1/4 arctan 0 squared over 2. Arctan of 0 is 0 because the tangent of 0 is 0. So this will just be all 0 right here. Square root of 2 squared is 2, and 2 over 2 is 1. So this is actually 1/4 arctan of 1. So I actually can think about on the unit circle, the things that give me a tangent of 1 are here and here. But arctan is just this half. And so this one right here is pi over 4. And we have root 2 over 2, root 2 over 2 are the coordinates. So the tangent is y over x, and that would be 1. So we know the tangent of pi over 4 is equal to 1, which means the arctan of 1 is equal to pi over 4 because it's the inverse. It flips the y and the x. So I know then this arctan of 1 is really just pi over 4. So that means that this right here is pi over 4. So I can sub that in, and I will get 1/4 times pi over 4. And so top times top, pi over bottom times bottom, 16. So I actually get pi over 16 as my answer. Okay, as always, please reach out to me if you have questions. I know this arcsin trig antiderivatives sometimes confuses people. So please reach out if you have a question, and good luck.